Today in class 9th we will study third chapter, that is force. So what is a force? Force is an external cause by which the body change its state of rest or motion, or change its shape or size, or the direction of motion. So in force we will study contact and non-contact force. So first, what are contact forces? The forces which exist due to actual physical contact of two bodies called contact force. And non-contact force, the force which exists without actual contact of bodies called non-contact force. So in contact force, let's see the example like frictional force, like normal reaction when a body is kept on a table. So the action reaction between that two bodies is known as normal reaction force. And you must have seen, suppose that a ball is hanging with a string, so it is a normal reaction or tension force. So these are the example of contact forces: frictional force, normal reaction force, air resistance, applied force. And example of non-contact force, there are three examples: gravitational force, electrical force or electrostatic force, and magnetic force. These are the three non-contact force. For these forces, the actual physical contact is necessary, but for these forces, actual physical contact is not necessary. Means these forces exist even the body are not in actual physical contact. So you have to learn contact and non-contact force and their examples. Now, you have to learn the general characters of non-contact forces. You have to learn, means what are the characteristics of non-contact force. The simple characteristics you have to learn that non-contact force does not depend upon the medium between the bodies, like gravitational force does not depend over it, but electrostatic force depend. So the gravitational force is always of attractive in nature, means gravitational force is always attractive in nature, whereas electrostatic and magnetic force can be attractive or repulsive. This is the main important fact, that the gravitational force always attractive in nature, but electrostatic and magnetic force may be attractive or repulsive in nature. The magnitude of non-contact forces depend on the distance of separation, means if the distance between the two bodies is large, then the non-contact force will be less. Between them, it decreases with increase in separation. If the distance is increased, then the non-contact force will decrease. These are two main important general characteristics for non-contact force. Now, new topic, we will study Newton's laws. We know very well that there are three laws given by the Newton first law. It is also named as the law of inertia. So what is Newton's first law? Newton's first law states that if a body is in the state of rest or motion, will keep on in the same state unless an external force is applied. Why the body behave like this? Due to inertia. That is why Newton's first law is also known as the law of inertia. Let's see the Newton's first law. An object moving at a constant velocity keeps moving at that velocity unless net force acts on it. Means if a body is moving with constant velocity, will keep on in that same velocity unless an external force is applied. Second, if an object is at rest, will keep on at the state of rest unless an external force is applied. Third, if an object is in motion, it will stay in motion unless a net force acts on it. In general form, we can say if a body in the state of rest or motion, will keep on the same state of rest or motion unless an external force is being applied. Why the Newton's first law is called law of inertia? Because, let's see, because the inertia is that cause by which the body resists to change its state of rest or motion. Inertia. What is inertia? Inertia describes how much an object tries to resist a change in motion, and On what factor does the inertia depends? It depends on the mass. Greater the mass, greater the inertia, we need larger force to change its state of rest or motion. Now, Newton's second law. What is Newton's second law of motion? Learn this. The rate of change of momentum of an object is directly proportional to the applied force in the direction of force. Means the rate of change of momentum is directly proportional to the force applied and directed in which the force was applied. This is the statement of Newton's second law, learn, and this is the proving. In Newton's second law, we have to prove F is equal to ma. We know very well F stands for force, m is mass, a is acceleration. So let's see. Suppose that a body of mass m initially moving with velocity u and then moving with velocity v in time t under the influence of force F. Then initial momentum is equal to mass into velocity. So initial momentum P1 is equal to mu. Final momentum P2 is equal to mv. So change in momentum will be P2 minus P1, that is mv minus mu. M take out as a common, so it will be m bracket v minus u. Rate of change of momentum, wherever the rate is spoken, then we have to divide that equation with time. Then rate of change of momentum means m bracket v minus u upon t. We know very well this is a statement, the rate of change of velocity. The rate of change of velocity is called acceleration. So directly you may come here, v minus u upon t is equal to a. So instead of this we can put a. So ma. What is rate of change of momentum is called? Rate of change of momentum is called applied force. So means this is rate of change of momentum is force and m into a, that is m. So F is equal to m. Learn this proving and write in copy. Then Newton's third law of motion. What is Newton's third law? It is also known as action-reaction law. So the statement of Newton's third law is that there is always equal and opposite reaction for every action. There is always equal and opposite reaction for every action. That is Newton's third law of motion. Your action caused a reaction. Your pushing on the wall caused you to roll backward. Well, means if you push the wall, what would happen? Wall will not move. You will be pushed back because of reaction. So very important question arise on this. Does the action or reaction acts on the same body? Answer is no. Action and reaction acts on different bodies. Now see, the unit of force. We have three units of force: SI unit, CGS unit and gravitational unit. The SI unit of force is Newton, that is kg meter per second square. CGS unit of force, that is dyne, gram centimeter per second square. Learn SI unit, CGS unit, and then gravitational unit. The gravitational unit kgf and gf. 1 kgf, the relation between gravitational unit and SI unit of force. 1 kgf, 1 kilogram force is equal to 9.8 Newton, and 1 gf means 1 gram force is equal to 980 dyne. Learn it. So this whole topic you have to cover and write in copy.